So over the weekend, everyone started more or less to look into SQL and to, we ran through a few tutorials, read a few readings and things of that nature. How many people found it easy? How many people found it not so easy? I've heard mixed things. What was your experience with it?
It started out I liked what you guys wrote.
Yeah.
At the beginning of that, that was great. That's sort of the first thing we kickstarted.
Sure.
But then some of the testing going through, it was either you're right or you're wrong.
Yeah.
And then there was no hey, you should do this. You're just kind of okay, what do you do? So that frustrates me. Okay, so now I get to do the Google search thing.
Yeah. That's the joy of SQL. It's either you're right or you're wrong. There is very little in between. Whereas opposed to something like Ruby, where it's it might work. I'll give you very descriptive things that I'm going to say are right and wrong. But in terms of SQL, it's either you're just right or you're wrong. There's not much middle ground, unfortunately.
Yeah, it's disappointing that a tutorial wouldn't obviously we don't know what the hell's going on. Yeah. So it would have been nice.
That's fine.
There were some places in the tutorial that were helpful where it would say, this is the symbol for exclude, something like that. They would just have one single bullet. Now it's helpful.
Yeah.
But a lot of the time you just conjugate this into mean whatever. And
sure.
Just didn't have any additional pointers.
It goes from 0 to 100 real quick, right? That's what you're saying, right?
I just would have liked some elaboration where a certain symbol would need to be included.
No, that makes sense, Alex.
Yeah, I didn't like the way the tutorial was so much. They give you a little bit of information, then they give you a little bit more. They don't really tell you okay, this operates on a whole column, or this operates, when does this operate on? Does it only operate on some results? And then it did have some that were multiple answers, like the join.
Mm-hmm.
You could use a whole bunch of selects, or join it to another one.
Yeah.
So it seemed like there were multiple ways.
Let me remodify. There's multiple ways to join things and to get the data that you want, but there's only one right way to write SQL. And if you misspell something or you miss it, you don't have a certain clause to join two tables together, then it's just not going to work. But with that, we'll go and kind of jump into what we should have done over the weekend, but we don't, since I'm not teaching over the weekend, it's week 4. Here we're going to do the introduction to SQL. Have people done SQL before, ever? What context did you use SQL?
Just for business stuff, creating databases and things like that.
Okay.
Get that data to do analysis.
Okay, so someone granted you access to their production level database and you were able to kind of go in and query things?
Yeah, or help actual data analytics people with queries hey, I want to do this, and something like this.
Okay.
And they would actually do it.
Okay.
But yeah, we learned some of it.
Cool. Nikki, when did you use SQL? Okay. Okay. Cool. Anyone else, or is this the first time you've dealt with SQL? Cool. All right, so this will be review for some, but mostly new for everyone else. And why can't I go up and down? There we go. All right, so SQL. When we're talking about SQL and we're talking about databases in general, there's 2 halves that we're going to talk about. We'll talk about both today. So the first half is basically a storage mechanism. How are my tables named? What are my columns looking like? What kind of data is included in my rows? And the other half of it is basically how do I query my database in order to get some sort of result out? So there's, again, like we said, there's 2 halves to RDBMS, which is relational database management systems. It's basically how do I manage the data that I have? That's exactly what a database is. It's a place that I just dump a bunch of data, but there has to be a clear way of how I'm going to interact with that data. First half of the first half of the database system is how am I going to store it? What tables am I going to need? What columns am I going to need on those tables? And what kind of data is going inside each row? And then how am I supposed to talk with the database? How am I supposed to insert things and get things out using the language of SQL, structured query language? The first concept you more or less need to know is tables. This is essentially what a table looks like. It's like a graphical representation of the, it's not really graphical. What you're seeing is a graphical representation of the data that a general database might have. Let's say we're talking about like a high school database system right here. And we have students, we have the table, which is like the entire students thing. We have the column, which refers to each individual like piece of information for any individual student. And then finally, we have a row. The row refers to the like one individual entry inside of a database. So again, the database table includes the entire table, which consists of a column, which is one type of information, like whether it be ID, first name, last name, or on probation. And then row is that one individual entry with all of its data underneath its column. All of these together, the table, the columns, and the rows, create what's called a schema. A schema is basically like a database schema is a representation of the data that we want to have. We're basically focused on three things: table names, and column types. That's really about it. So again, tables plus columns plus rows equals our schema. Schema is basically like, what other tables do I have inside my high school system? What rows am I going to need inside of those? And then what type of, like, what kind of data am I going to be putting inside of my database? More specifically, when we're talking about tables, tables are identified by names. And the way that we create tables using the SQL language is create table blah. And that blah is usually a noun, a plural noun of some sort, and it's usually going to be lowercase with the snake case through it. It's also a pretty good idea to make sure, especially in your SQL databases, that you have a unique identifier for every single row so that you're able to find every single, you're able to find something by an ID number rather than like a first name or something like that. These are some table name examples. If you're talking about a database with a table that's going to store people, you might want to call it persons. If you're creating something like Amazon's purchasing system or something like that, if it's storing a purchase order, you're going to create a table called purchase_orders, lowercase and plural. Finally, if you were storing something like liking a post or something like that, you write something on Facebook and a bunch of people like it. That's also all stored in a database, and then you might want to store that as likes. So we talked about tables. Tables are basically the outermost thing. You know, if we were talking about like the budgeting thing over the weekend, we have many categories. Categories might be something that's like an entire table. Specifically on that category, we might have things like an ID number, because every single SQL database table is supposed to have IDs. We might have something like what's category? Like the amount that you're allowed to spend, the amount that you've currently spent. Then perhaps the name of the category. That might be something that goes onto your budget. We are creating a table called students. Students is the table name, and all of these things, the bolded part on the left here, this ID, first name, last name, and on probation, those are specific columns, like specific data, like name, like what you would want to call. What am I trying to say here? It's like the columns are human readable for you. You know, it's kind of like how do you want to say, like, if I want to select all the first names, you would call the column first name. If I want to select all the last names or all the birthdays or something like that, that is this portion on the left. On the right side of it, this bolded section on the right, we have column types, which is basically what type of data am I allowed to store inside of my database here. Obviously, for someone's social security number, if you were going to store it all as just numbers, you probably wouldn't want like a date in there. You probably wouldn't want a string in there or a true or false value. So you want to, SQL is very, very specific on what kind of data type you want to put inside of the database. For all IDs, they said, I want an integer, because ID numbers go 1 through whatever. So those are specific just integer data types. I just want that kind of data type to be going in and out. First name and last name, this varchar here. Varchar is just a fancy way of saying just text up to 255 characters. It's just a string being stored in at 255 characters. And then on probation is a Boolean. It's saying I'm only going to accept true or false values. So within the SQL world of databases, there's many different flavors of SQL. So there are, like, you may have heard of Oracle, you may have heard of MS, Microsoft SQL, MySQL, we did Postgres, we also installed SQLite. Those are all flavors of SQL. Like different, like there's pretty major differences in terms of performance and things of that nature, but it's all a SQL database. It still includes a bunch of tables, which include rows and columns, and each one of those rows and columns have specific data types that is allowed to be put in. But these are ones that are going to be common between all SQL databases, no matter what, in terms of data type. So integer is always going to be numbers. Decimals are always going to be decimals. Varchar is always going to be text up to a certain, between 1 and 255. And then there's going to be text for anything greater than 255, date and timestamp. These are things that are going to be common to all flavors of SQL. So let's say you're writing the first ever version of Amazon, right? When Amazon first came out, it was just an online bookstore, which was an absolutely ridiculous idea at the time because Borders and Barnes & Noble basically dominated the market. When they first started, they probably had like most people, just a very, very simple database. Maybe I have a database of books and a database of publishers and customers. Maybe just as simple as I have a database of books, a database of orders, and a database of customers. That's all I have. But as time went on, they started selling more things. They went beyond books. They went into products. And before long, they became an online marketplace where a lot of companies could sign up and basically they run their business through Amazon for the exposure. And then they had to deal with reviews, and then they had to deal with, family accounts, and then a lot of credit card processing, and then they had to worry about like Alexa and that whole other world of things. You can kind of imagine that when they started in the 90s, they couldn't nearly imagine their success today. And as they are getting bigger and bigger, there are new databases being added all the time, and old ones also being dropped. You're going to need to modify your schema a lot. So whatever you usually start with in terms of when you start writing programs, as you can kind of see when you were starting to write things like the budgeting app, you think, okay, at this point, I can probably make this into a separate class. That separate class is going to be basically a separate table. You're like, how much more can I abstract this? So yeah, as you're going to maintain and write new software, you're going to create a lot of new classes. Each new individual class that you create is going to be a new table on your database. Yeah, I think the main point of this slide, just to avoid reading this wall of text, is you're going to make a lot of modifications as you go along. You might decide that F name is not good enough. Like it might be, I might want to type out first name. Yeah, I might not handle credit card payments today, so I don't have a credit card payment table, but eventually down the road, if I want to save on like operating costs like that, then I will just, then I will have to create my own credit card table. Just as a quick side note, if you're ever deciding to start a business after Code Platoon in any fashion, don't create your own payment processing system, because there's a lot of specific ways to hold the data, and there's specific laws on like how you can store and collect credit card information. And if you don't do any of that, they can sue you very quickly. So there are a lot of people going online just trying to find these small places, like these small websites, finding some sort of small loophole and exploiting the crap out of them. Just don't handle payment processing. There's other companies that dedicate their entire companies towards it, and you should just let them do it. So Braintree, PayPal, and whenever possible, check out with PayPal. Don't check out, like if you're at Target.com, you have an option to just check out with your own credit card information, or check out with PayPal. Just check out with PayPal. They do it better than Target.
sounds like there's a story there.
What's that? No, I mean, that's just mostly like a safe. It's really just a safety thing. Like, you know, the big box stores aren't as, I mean, they are up to date technically, but they're just not as good at handling things like credit card payment processing as someone who dedicates their entire company towards that. So it's just better in general to let the professionals take care of that. We talked about this quite often. This applies also to SQL databases. Single responsibility code means that successful software is built from small modules that do one thing well. Your classes should do one thing. Your methods should do one thing. Your variables should store. Nah, well, that's arguable. Your classes and methods should do only one thing. And if they do more than one thing, it's probably ripe to, you know, move into something else. Yeah, smaller is always going to be better when you start talking about developing software. So that kind of mentality also relates to SQL databases. So let's say that we had one table that stored way too much stuff. So we have this one table right here. It has all of these different columns that go vertically, and then all these different rows. These are just entries. Now we have, let's say this is called students. We have a first name, last name, on probation, line 1, line 2, city, state, and zip code. Is this single responsibility, would you say? How would you split this up here?
Their name and address, one, name and probation status.
Yeah, that's probably good. Yeah, so I have like the first name, like these three could probably be fit together. Like this is the student's name and like whether or not they're on probation. But this one is, this section here, you can kind of think of like, can I classify this completely differently? And in terms of this one, it's like these 5 things put together create an address. And because it creates an address, maybe I want to put that, maybe this is not a single responsibility table. Maybe I want to push this into another table. And that's exactly what we're going to do. We're going to split up this first half right here into students, and then we're going to split the second half here into addresses, into 2 different tables from one giant data set. Yeah. Another thing as we're thinking about creating our SQL databases and things of that nature is the concept of don't repeat yourself. You don't want to repeat the same data in 2 different pieces, in 2 different databases, because databases are not terribly, I mean, they're not expensive, but they're also not cheap. Yeah, go ahead.
So in that last example, how are you going to know addresses associated with down or Elba?
I really like that question. We're going to get to that right now. So we talked about this a little bit earlier. Actually, we'll get back to that in like 2 slides. So this kind of goes into the don't repeat yourself methodology. We're doing single responsibility because we've separated the students. We've kind of split up the students from the addresses here. But there's repeated code right here. We have this first name and last name. It's on this addresses, but it's also here on the students. So the idea is, how do I get rid of all of this extra garbage right here? And something you have to think about, the question is, so we're throwing all these things at you, like don't repeat yourself, single responsibility, everything. But you can kind of think of, what's the issue if I duplicate the code right here?
Stores is 2 entries, but it's the same entry.
That is also true, but what if somebody you change your last name, right? Your parents, your mother or father gets married, and it's like a stepfather, a stepmother, and then they change the last name. Maybe your legal last name is also going to be changed. If you decide to change your first name or middle name or something like that, then you have to update it in 2 places. At one point, you'll have like let's say like this is super up to date, and then this one is super out of date, and then you have the wrong name, and then use this table to register for the SATs or something like that. All of a sudden, your ID doesn't match up with your ID doesn't match up with the name that they've given. Keeping track of data in 2 places is just like a pretty bad scenario. So what's the alternative schema to eliminate this duplication? This kind of goes along with Taylor's question. What we'll do at this point is say we're going to have 2 tables. One of them is called like students, and one of them is called addresses. So we're doing that single responsibility code. And the other one is don't repeat yourself. I'm not repeating any data between one or the other. But what I've done here, instead of actually storing everything inside of all the address information on students specifically, I've split it up into a second table. And using that unique identifier here, I'm just going to associate student number 1, whose name is Tiana Lowe, has an address. And that address has an ID of 4. So instead of everything living here on the students, I'm just going to associate it with addresses. And then I can join these two tables together and get that person's address. So does that kind of answer your question?
No, it does. It just seems like it's a complicated process. But I'm sure it'll make sense later on down the road.
Well, it also kind of goes along with don't repeat yourself. If you have let's say you have twins in your class, right? Then you would have 2 people with the same. You'll have 2 different people with the same address. So you're duplicating code at that point. And it seems like a very trivial thing now. Like it's fine, just write everything in one place. But as your database starts getting larger and larger, so like Amazon when they first started probably only had 1,000, 10,000, 100,000 customers, and now they have hundreds of millions of customers, right? So it's like I need to optimize this ahead of time. There's an entire if you are really interested in SQL and want to become a SQL expert, there's actually an entire field called database administrator, DBAs, that like large companies will hire because their databases are just so huge.
What if somebody lives with their mother and father are divorced and they live with 2 different
That's actually a great thing. That's something that you have to really think about too. In that case, you can think of it as like a student has many addresses, right? Because they can literally have two places that they live.
And could you put multiple address IDs?
We will get to that. That's called a join table. But basically, it's kind of like when let's say a student in this relationship right here, we can kind of think of it as a student has an address, and an address belongs to one student. What if a student has many addresses, right? What if they like you said, their parents are divorced and they have 2 different places? That means a student has many addresses. An address can belong to many students, right? Let's say, or even if you're taking it a step further, let's say you have a brother and a sister, and they both have that same double address, right? Sometimes they live with their one parent and another parent. You're going to need a table in the middle to join the student to an address, but we'll talk about that more a little bit later.
Or really, you could just substitute. I mean, for ID, to have 2 separate tables, you could just have student ID and the addresses, and that would suffice, right?
Yeah, that's another way of doing it. Yeah. All right. Something else you want to think about when you're talking about data integrity, and I have a real-life example of this. Divvy Bikes, if you're listening, I'm talking to you. Oh, no, Ventura Chicago, I'm talking to you specifically. Data integrity. When you design a schema well, and again, this is one of those things where you want to think 10 times and then code 1 time. It's very easy to create a database and to insert data right at the beginning to get something off the ground, but it's very, very expensive later down the road. Once you have 10,000 records, 100,000 records, 1 million records to transfer it all from one area to another area. You want to design your schema as carefully as possible. And you want to make sure that you want to use constraints of things such as column uniqueness or not null to prevent yourself from situations like this. So if we take a look at this one table, this is called users. It has 3 columns, and then as of right now, it has 2 rows that we see. If we have an email of james@example.com and james@example.com, how is the database supposed to know which password to check on the way in, right? Because it's kind of like when you log in with your email and your password, if you have 2 emails that are exactly the same and they have 2 different passwords on there, which one are they going to check? And this is a real life example for many places like Ventura Chicago. Again, if you're listening, Ventura Chicago, I'm talking to you. I had to call into customer service because my Ventura card was associated with my personal one and my school one when I was going to graduate school down here. So I had a student account that was $100 for 3 months, and then I had my regular civilian account. whenever I would log in, it would take me to my other login page, my student one. I was like, I haven't been a student in 3 years. I need to change this. And then every now and then it would magically switch. So it would like get me into my regular user one. And I was like, this is ridiculous. So I called it. I was like, I have 2 accounts. They're like, oh yeah, sorry about that. Which one is active? And I said it was the regular one. They're like, okay, I'll just delete it. But I'm able to log into 2 different accounts. That's not exactly the greatest. You can kind of think, what would happen if, I mean, my name is pretty popular. It's Jonathan Young, right? And there are people with my name and my birthday who also live in the same city, which is kind of creepy. That's what they told me for when I was calling into a call center. They're like, there's a lot of Jonathan Youngs on here. So I gave them my birthday. There's a lot of those here. Which city do you live in? Chicago. There's 10 of you. I was like, oh God, like someone could literally just take over all of my entire life. That's a different story. But you want to make sure the data that you have in your database is you have to take care of don't have duplicates in there. Like don't accept numbers when you're only expecting letters or something like that. On this right side, does anyone's password actually look like this? What's that? It's quite a password. I knew someone whose password was Apple123 from one of the classes.
Nice.
Kid you not, Apple123. I was like, that's not a secure password at all. And what you'll see here is that these are considered strong passwords. No one has any idea what is going on here. These are also called hashed passwords. So that person's password of Apple123 is not stored as Apple123 in a database. And you can imagine why. If somebody hacks your website and it's stored in plain text, so Apple123 instead of this PEA, like this nonsensical looking string. If it's stored as Apple123 and you have like 100,000 people's worth of data, people usually use the same password to get into their Amazon account, their Chase account, their mortgage and everything like that. You might be victim of this as well. I know I definitely am. So you want to protect 2 things. One, don't have Apple123 as your password because it's really easy to guess. And then once somebody has your password for one site, they probably have it for most sites. 2, make sure you're having multiple passwords for multiple things. And 3, if you learn anything from this course at all, it is never store passwords in plain text. Always hash it on the way in. So Apple123 will come in, your code will do something fancy to it, and it'll be saved as this nonsensical string. So that even if somebody decides to hack in, they don't know what the actual password is. They don't know what hashing software you use to get in.
If they know enough real passwords and they solve that hash,
yes.
how many, what's the, if they know 2 real passwords, could they figure out that?
Yeah, they could.
So if they had their own account.
So so there's a way. I'm not exactly terribly keen on this. So the question is, if I know that Apple123 equals this, and then Blueberry123 equals that, can't I figure out the hashing algorithm used? And the answer is yes. But the issue with that is that there's so many different combinations, and your website will only allow a certain number of hits on your user in a certain amount of time, that I think each password will take somewhere in the vicinity of like 1 million years to break if you tried out every single possible combination with the time blocks in place. So I think it's not worth it for them at that point. But yes, once you get into like quantum computing and things like that with like supercomputers, they can break this in a matter of seconds. So nothing is perfect. That's just how it's going to be. But you want to protect yourself as much as possible.
So our Caesar cipher isn't impenetrable? Is that what you're saying? We wasted our time putting together a Caesar cipher.
I mean, if you're writing code and you're like 7 years old, yes, it's very secure. Your parents won't know. But other than that, you want something a little bit more secure. Again, another one of those things is when it comes to like hashing algorithms for your like saving passwords, don't do that on your own. There are PhDs from like Stanford, and there's literally a service called encryption is a huge deal now. Like secure communications is the hot topic, and cybersecurity is another big hot topic. We're gonna have a couple people coming in to talk about that. There are people much smarter than you and I, and basically quite honestly, all the brain power in this room making these hashing algorithms and making it so that it's very, very difficult to break these types of things. We just kind of let them do their thing and we do our thing. Like they can't write programs as well as we can, and we can't create secure hashing algorithms as well as they. There's a lot of math going in behind it. So we just talked about a whole bunch of stuff revolving around creating your databases, what a table is, column is, and like keep single responsibility, don't repeat yourself. Now, once I've designed all of that, how do I write data into the database? Like we were writing stuff into CSVs and reading stuff from CSVs. How do I write stuff in and get stuff out? We're going to be using a bunch of queries. And in SQL, all the commands are basically called queries. It's the act of getting and receiving things out of the database. So yeah, most often you'll be creating a table with the following commands: select, insert, update, and delete. They're pretty self-explanatory, but just to be absolutely clear, a select statement in SQL basically says, like, get me the data out of, like, select something from something where some condition is met, right? Give me all the people, if it was one giant military database, right? Give me all the people from the Air Force who are 27 and older or something like that. Or if you're doing budget cuts for like chase.com, which happens quite often, if you're doing budget cuts and you're laying a bunch of people off, or you're working just for a large organization, not just to pick on Chase, what they're going to do is they're going to say, like, I need to lay off 10% of my workforce. Give me the 10% that are the oldest and being paid over $200,000. We'll probably cut them first, or something like that. So that's what a select statement does. You tell me, like, give me this kind of data out of the database. Insert is the opposite of select, in the sense that I'm pushing something into the database. I'm not getting anything out, instead I'm pushing it in. Update is for things that already exist inside the database, where it's saying, like, oh, find me like this class of I don't know, soldiers, and everyone in here is going to get bumped to pay grade or something like that. I don't know if that's actually true. Probably not. But it's kind of like, or even like an individual. It's like, find this individual in the database and bump their pay up 1 grade. And finally, delete, self-explanatory, deletes a row or a series of rows from the database. Okay, give me all the people who are retired over 30 years. I don't want them in the database anymore. Just clear them out. So select is by far the most common query. So the way that this works is, I think that goes into some more detail. This statement is a SQL statement right here. Select, and these are all case insensitive, so you can do capital, you can do lowercase, it's up to you. I generally do capital for like SQL specific things, like select is a SQL thing. From is a SQL thing. Students is like the name of your table, so I just kind of leave that lowercase. So it's select star from students, basically saying select everything. The star is a wild card, saying select everything from students. So it'll give me every single row. If you want to be more specific, instead of selecting everything, you can just say, like, I just want the ID and the first name from students. So I want you to select, that's the big SQL query. What do I specifically want you to select? I want to select the ID and the first name. From which table do you want? Students. That's what we're getting here. Sometimes you want to be more specific, like select the ID and the first name, or, you know, if you're firing a whole bunch of people, so give me their first name, last name, and phone number, where their age is above, you know, is near retirement age or something like that. So this would be select ID, first name, from students, where, and a where is one of those. I guess it's a clarifying condition. Yeah, it's a clarifying condition where the ID is going to be 2. You're selecting only specific things rather than all of them. When it comes to where, there's a lot of stuff, and you have access to these slides, so you can kind of take a look at your leisure as well. There's a lot of conditionals that are supported by the where clause. So the most popular one, obviously, for you is going to be equals. It's like select all the students where, like, their grade is equal to 9 or something like. So that's all the 9th graders or something like that. This bang equals is, and this less than greater than sign, basically not equals. That bang just negates everything. It kind of goes across it goes across all the all languages. We have greater than or equal to, less than or equal to. Again, it's one of those things where it's select for me all the students in this college who are under 20 years old. So that'd be select star from students where age is less than 20. Then you have the between. It's between two different values. Like give me all the 19 to 21-year-olds in this town. In, which is kind of like, is basically like, I'm going to provide you an array of potential. I'm going to give you an array of potential things that I can match up with, and then you select what's in there. So it's like, just give me all the soldiers in like the Air Force or the Marine Corps. And then finally, like is basically it matches a string with wildcards. So these are some pretty specific, these are just like some small examples. This one's pretty straightforward. This one's also straightforward, just basically where the grade is not A. Select everything from the classes where the credits are between 3 and 4. So like not, what's the most ridiculous thing you got college credit for?
Camping. I had a substitute gym class.
Okay.
Where instead of holding the semester gym, we could go overnight camping.
Oh.
Were you at school Berkeley?
I had one called, I was a music major in college for a little bit. One was called Alexander Technique, which is basically how you can breathe effectively and use your breathing to walk effectively. It was 100% based off of attendance, and you only had to show up for like 60% of the classes.
You still practice this technique?
What's that?
You still practice this technique?
I do not. No. So it's kind of like where the credits are between 3 and 4. I think I got like 1 credit for that or something like that. Select star from enrollments where grade in A and B, where it's like select all the enrollments where the grade is either A or B. That's this in. That's what it means here. And then finally, this last one with the wild card, this percentage sign. Select star from classes where named like art with a percentage sign. So this like basically means give me a class. Select everything from the classes where the name of the class has art at the beginning and anything afterwards. If I put this percentage sign to the beginning, it would say, give me the classes where the name starts with anything but ends with art. So modern European art or American art in the whatever. None. And the credits is greater than 3.
Sorry, you said that was before or after?
Yeah, so basically this wildcard means like it starts with art and finishes with anything.
Oh, it has to start with art.
It has to start with art, yeah.
So it can't be like American art.
No, but if I move the percentage sign to the front of art, like I just moved this here to the front, it would be starts with anything but ends with art.
Can you do both, like beginning and end?
Sure, you can put a percentage in the front, so it's like anything at the beginning, art in the middle, anything at the end.
Okay.
Modern art in America or something like that would work for that. All right, so when we talk about insert is basically the opposite of select. I'm putting stuff in rather than taking things out. And this is very procedural. This like SQL is a very procedural language. The more and more you do it, more it's going to make sense. Insert into students in this specific order: first name, last name, birthday, and the values of that are Michelle DuPont of February 11th, 1982. I'm inserting into this particular table, into these particular rows in this particular order. That's a key here. Michelle DuPont, 1982. Update basically says I'm going to find something inside your database that already exists. And yeah, I'm going to find something that already exists, and I'm going to update it. So I'm going to update this particular table. I'm going to set line 1 equal to 200 Church Street and zip code of this, where the ID is equal to 2. So inside of addresses, they're going to find where the ID is 2 and get that record, and they're going to set line 1 to equal this instead of what it was before, and the zip code to equal that instead of what it was before. This is somewhere next, I'm pretty sure. And finally, delete. Very, very simple. Delete from a certain table where the ID, where some condition is met. So it's like delete from addresses where ID equals 2, delete from like students where names are Jonathan, so they just delete all the Jonathans in the school. They don't want Jonathans there. You want to be careful with update and delete conditions. You need to have some sort of thing to basically dumb down the number of, you need to be more specific with delete. Because if you do update address set line 1 and all that without this extra where ID is equal to 2 and this where ID equals to 2, you're basically saying everyone is going to move to 200 Church Street in Evanston. And that area is, while it's nice, it's not that large. But so you want to be very sure to do that as well. If you do delete from addresses without ID equals 2, you just deleted the entire database. You will destroy production level data at your first job. So make sure that before you run any big SQL queries, you run it by your boss so someone else can blame. There's someone else to blame as well. Yeah, you want, yes, basically that. I did do this at Groupon one time. I caused a multi-million-dollar blackout. So basically, I was trying to update some. I wrote a SQL query, and I didn't run it by my boss, and it started running, and it wouldn't stop running. Like I just didn't know, I couldn't like kill the machine or anything like that. And I was basically connected to the production level database, and all of a sudden, like this big VP of engineering comes into my our like Slack channel and goes, "Who is Jay Young?" I was like, "That's me, sir. I just started 3 months ago." And he goes, "Oh, okay. Well, you just blew up like the production level database for 20 minutes. We just lost like $40 million." I was like, "I'm so sorry. Please don't fire me." And my boss was like, "Don't worry about it. Like you're brand new. This stuff happens." I was like, "Oh, really?" Yeah. Like, don't worry about it. Next time, just make sure you come to me and show me the SQL query before that happens.
When you say production level, does that mean the client-facing code that's directly affecting the website? Is that basically?
So the context of this one, so production level code generally means that, like, what does the customer see? What's currently outside in the world and on the internet? When it comes to databases, there's going to be different types of databases. There's going to be development databases, which is the stuff that you do on your local machine, doesn't affect anybody. Test level databases also on your machine. Then they have something called staging databases, which is basically a sandbox copy of your production level database. So it's just a copy. You can do whatever you want. You can blow things up there and it won't affect production. And production is what's being used in the background. When you go to Groupon.com and you make a purchase, that's hitting their production level database.
So you get something like a whole lot of free massages.
What's that? No, I was trying to I think what happened was, so we have this ability to like refund stuff to Groupon bucks. So I refunded, but I didn't must have not finished a clause or something like that, or I missed something very small, and then it just kept refunding people. Yeah. So yeah, just be aware that if you're not messing up at your first, I felt so bad, and my boss said why don't you take a walk with me? And I thought I was getting fired. And then during that walk, he says you're breaking production. I was like, I know, and I thought this is it. I'm getting canned after 3 months. He says, that's good. I was like, really? He goes, if you're not breaking production, that means you're not doing anything valuable enough at this company. And I think that's how a lot of people feel. If you're not breaking production, if you're not pushing to master by accident, that means you're not doing anything on your own. And they expect those types of mistakes from you all. That being said, do try to minimize them as much as possible so you don't cost your company millions of dollars. I think that's about it. That's all I've had. Are there any questions on the basic SQL intro level? Again, SQL is just the language that we use to query, to query meaning get information from and put information into a database. Database is just a way, a system to organize your data. Your filing cabinet that has all your important documentation is a database of some sort. Your brain of how you manage your finances or something is a database of some sort.
How is this going to work with CSV? Are we just going straight to SQL now, not working with CSV anymore? Yeah, so
CSV, the reason why we did CSV last week was basically is an intro to databases in terms of I want to Instead of just writing it in memory, I want to actually write it into a file and read from a file. In real life, everything is done in Excel for business people, and whenever they need to enter anything into the database or grab things out of a database, they're going to give you a giant CSV file. You have to be able to parse that and then insert things into the database from that information. Otherwise, imagine going one by one, just entering it in. That's not efficient. So they're going to give you a whole list of like, hey, can you get all these new leads in this particular region? Here's the CSV of it. Just insert into the database for the salespeople. You know, so you would have to read all of that kind of stuff, go through every single row and insert into the database, and it's pretty fast when you use a computer.
Okay, so can you explain the transition between Excel or just the lines Excel and CSV and SQL? Like, how do those? I mean, so John was saying like his company they use Excel a lot.
Yeah.
So how does that? How do you?
Sure. Let's take a look at. Let me create a new driver. Maybe there's something appropriate for me. Did we go into the open data for? It's open data Chicago. What is it?
What do you install on a computer?
SQLite and Postgres. SQLite is good for like dummy little projects, but it doesn't scale. Postgres is the new agreed upon like thing that most people use. So we have this City of Chicago data portal, right? And let's say I wanted to. I think we were nosy last time we went into salaries. Salaries. I'm going to grab this and just download it. Okay. That would be helpful for me right now.
Yeah, it's in Slack.
Oh, it's in Slack?
But I don't know how far back.
Okay. All right, so your question was kind of like, what's the difference between Excel and CSV and stuff like
just
that?
like how are we using SQL now when given like Excel document? Like an operations team would be working probably from Excel.
Sure. So Excel is just like a program, right? Just kind of like Microsoft Word is just a program. You can save something as a doc or docx if you have a Macintosh. You can also export it as a PDF. So that's just, you know, in order to read a doc file and edit it like you would in like a regular doc file, you would need to open it in Microsoft Word. So similarly, Microsoft Excel or Google Sheets or whatever is just software to do stuff with tables, spreadsheets. You can export it as a XLC or something like that. I don't know, whatever the extension is. What's that? XLS. That's an Excel spreadsheet. Or you can download it as a CSV. Like those are two different like file extensions, but they contain the same data. So that answers half the question. The other half of the question is like, how do I bring CSV into the database? Don't worry about that quite yet, but it's kind of like if you were to read the data one line at a time and then you have a specific table, you can just kind of like insert into blah, 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 first name, last name, blah, 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 and you can just kind of iterate through each individual row, and then you can insert that stuff into a database that way.
When you update our data in the SQL, you can go directly to the database.
That is directly impacting the database, correct?
But you have to get that permission to be able to do that?
It depends on so your company should never give you permission on your first day to go directly into the production level database. So generally speaking, only specific teams have access to production level databases and can alter things there.
So it means when you work there, you have to like point your database to use someone to be able to.
No, you have to. So basically, what happens is, basically your database is going to live at another location. So you're just going to connect into that database, and then you have to provide credentials saying like, I am Mickey. This is my password, and they're going to say, Mickey, we see you on this list of people who can access this database. Here you go. Like now you have access, and you're directly there.
What staging is the database you could utilize if you wanted to play with production data and not have to actually modify that data in a detriment? And that if you were talking about coding, that would be the way you do it.
So it's maybe in that stage. So
we're not dealing with the production database. Basically like the production.
Yeah.
Is that how they would edit the actual production? They would have like a stage like Git, and then they would push it to.
So if you were to update the actual thing, basically what happens is somebody with write permissions, like basically like I can connect to the production level database. I will write a SQL query. I'm going to pass it off to my boss, and then my boss is going to run it, and then it's just going to update it.
So why not have a Git for SQL?
They're usually production level databases don't usually have Git on there because it's being updated so frequently. But what they will do is they'll keep backups of it every day. So in case that you're a very angry employee, you got a pink letter or something like that, you just say like delete everything from customers, delete everything from orders, and like that could happen. Realistically, it probably does. They have a backup of that somewhere, so they can just say like, we were down for 4 hours, but we have to move these 20 million records from the backup database into the main database right now. Any other questions? Cool.